Okay, hi Zach. Welcome to lesson number 102, and this lesson is going to go over absolute value inequalities. And trust me, when I saw this lesson, absolute value, I was like, oh, I totally know that. I mean, the absolute value of -4 is just 4, right? But it definitely gets a lot more complicated than that. And on some of these examples, I was like, whoa, this is crazy. So you're definitely going to have to pay attention, and hopefully you are smarter than me, because this was definitely a little bit challenging, definitely more challenging than I thought. First of all, what is the absolute value? I mean, this guy is saying, that's impossible. I can't have a negative blood type. Because you know how there's different, like you could be A positive, A negative. Here's this absolute value sign. He's thinking he's going to be A positive, and who knows, maybe he was something else, but I'm actually A positive. I'm not sure what you are. I don't think you've ever been tested that I know of, but anyway, you haven't had a reason to, so I guess that's good. So let's jump into the lesson. All right, here we go. The first point that they make about absolute values is that every real number, and now we're going to make the exception of the number 0 here for a moment, every real number has two parts. Now, I thought that they were going to say there's a positive one and there's a negative one, and guess what? I was wrong. They proved me wrong, so whatever, I guess. So the two parts that they think every real number has is either the positive or the negative sign. So it's going to be positive or negative. And then there's the numerical component. So if you're talking about like +3, the two parts are the positive sign. Well, here, let me do it in something that's going to stay. Here we go. The positive sign or the negative, if it is a negative. And the second part is going to be the number 3 itself. So the 3 is sort of the magnitude or the numerical part. So if you're talking about -1, one of the parts is this negative sign, and the second part is this numerical part, which is the magnitude of the number. And of course, that is referring to the bigness of the number. That's what she's, okay, I don't even need to go there. All right, so the magnitude of the number, or sort of the bigness of the number, we call this quality the absolute value of the number. So when you're talking about the number 3 and the number -3, they both have an absolute value of 3. Obviously, if you take the absolute value of that and you take the absolute value of that, you're going to get the same magnitude, even though one of them is a positive number and one of them is a negative number. The way I think about that, and they bring this up later, is like, well, how far away are you from 0 on that number line? And so these are the same distances from 0. There's 3 here, and there's -3. So the magnitude is the same, right? And then they just have different signs, but they have the same absolute value. Okay. What's the next? Okay. So when we're looking at the absolute value of +3, it's going to be 3. When we look at the absolute value of -3, it's going to be 3. So you designate absolute value, obviously, by these lines, one on either side. And these are both the same magnitude. Here, Michael Scott is like, can you explain this to me like it's like I'm a 5-year-old? They make the point that some authors don't really like that term, the bigness or the magnitude of it, I guess, because that sort of makes it seem like you're talking about greater than. And when you're talking about absolute values, the absolute value is actually equal. It's not like one of these is greater than the other one, because their magnitude in a way is the same. So I don't know, like if you're $3 in debt or you're $3 positive, the magnitude of the numerical value is the same. It's just the difference is the positive or negative. I don't know. So they said because some authors don't like it, there is a formal definition, and I'll go over that formal definition here in a second. Okay, she's saying, I'm not picky, I just have high standards. Yeah, some of these mathematicians I feel like are a little bit picky, but this is going to be the formal definition for absolute value. And the formal definition has 3 parts, and you have to pay attention to these as I go over it, okay? So let's talk about A first. If x is greater than 0, so like we're talking about the number 3, something that's greater than 0, then the absolute value of x is just going to be x. So think about a number that's greater than 0. 1, 2, 3, 5. When you take the absolute value of that, you just get that same number in a positive number. That makes sense. Okay, let's go over B. If x is equal to 0, the absolute value of 0 is going to be 0. So we're talking about real numbers here. This makes the case for what's absolute value when x is greater than 0. This talks about what if you're equal to 0, it's just always going to be 0. And C, this is the important one to pay attention to because this one can be confusing. Part C says the absolute value of x, if x is less than 0, so think about a number like -1, -3, -5, is negative x. So why? What does that mean? How can the absolute value of x be a negative number? Well, it's not a negative number. When they put a minus sign here, what they mean is this. If you've got the absolute value of -3, then they want the opposite of -3, which is a +3. Okay, now do you see that when you go back to this? If we erase that x and put in like the number, anything, -5, then you're going to take the opposite of -5, which is 5. So it is a positive, there are saying that, but if you have any negative number inside here and then you take the opposite, so that's why that minus sign has to be there, then the opposite of a negative is going to be a positive number. Make sense? Okay, so here we go. Formal definition. That's why I put this. She looks a little formal in this. So the absolute value of a non-zero real number is going to be a positive number. So even when you take into account this C, the absolute value is going to end up being a positive number because you're taking the opposite of that. Okay. The absolute value of a non-zero real number is a positive number. The absolute value of 0 is 0. Okay, so that's the rule. That's the formal definition. Easy peasy, right? One last time. Okay, so we're going to make sure that we understand this. Okay, the absolute value of 3 is going to be +3. Okay, the absolute value of -3 is going to be the opposite of that, which is +3. The absolute value of 0 is 0. Easy peasy. So that's sort of the attempt to describe absolute value of a number using words. But they also said that a lot of authors make the point that I made, which is the absolute value of a number is sort of describes the distance on a number line from the origin to the graph of the number that's being considered. So when we're talking about like the absolute value of 3 on this end of things, we go to 3, that's sort of x, and the absolute value is going to be the distance from the origin to that number, which is 3. And then this 3 that's written here is describing this distance, or it's describing the magnitude. On this end, we have the absolute value of -3. And when we take the absolute value of -3, they're saying, well, it's the distance from the origin to that number on a number line, to -3. So the absolute value is still 3 because the magnitude of how far you traveled is 3, even though it's to the left instead of to the right. And that's why the magnitude of these, or the absolute value of those, can be the same, even though you're taking the absolute value of 3 and you're taking the absolute value of negative 3. The positive and negative is just describing the direction. So that's why every number has two parts. You've got the positive and negative sort of describing the direction, and then the magnitude, which is going to be the absolute value of that. Cool, huh? Okay. Squidward is saying, why it's opposite day. Every non-zero real number has an opposite. So they say that the value of either member of a pair of opposites, okay, this has to make sense to you. The value of either member of a pair of opposites is the positive number of the pair. I thought they were going to say the opposite of this is negative 3, and the opposite of negative 3 is this, but that's not what they're saying. They're saying the absolute value of either opposite, so the absolute value of negative 3 or positive 3, is the positive one. In other words, it's setting up a problem like this. If you have the absolute value of x, or some number that you don't know, or maybe there's two numbers in here, x and y, and the answer is 4, what are the numbers that should be inside these brackets, inside these lines, right? So what's the opposite of this? It's going to be either 4 or negative 4. So let me say that again. Okay, maybe I'm not saying it right. The absolute value of either opposites, so they are saying that this is opposite to this, but the absolute value of any one of those is the positive one. The absolute value of either one of those is the positive. So if you have these lines, you don't know what is in here, but you're taking the absolute value and you get 4, then inside the lines is either going to be 4 or negative 4, both opposites. These are opposites. Okay. But the absolute value of either opposite is 4. Oh, that's hard. Let me hit you with some knowledge. I need some more knowledge on this. I'm not sure I'm getting it. So if you have the absolute value of x is equal to 4, the answers are going to be x is equal to positive 4 and negative 4. And if we graph that, it's going to be a 4 here and this negative 4 here. And so you can see that they're the same magnitude to the origin, just different directions. So negative 4, positive 4, the absolute value of either one is this 4. And when you graph it, it looks like this. And then guess what? It makes the point. You're going to have to graph every single answer. I know what you're thinking. Oh, fudge. But it's going to be fun. Moral of the story, graph all the real numbers that satisfy the inequalities. Okay, so there's going to be inequalities here, and it's going to get really hard really fast, so you got to pay attention. Assume that D, or the domain, is your set of all real numbers. And we're going to assume that for these examples. Let's jump into example 102.1. It says graph the absolute value of x is greater than 2. So it's not an equal sign, so it's harder. We've made it harder because we've put in an inequality there. So we're asked to indicate on the number line every real number whose absolute value is greater than 2. So let's think about it for a second. Okay, what if we put in the number 3? Whoops. Yeah, I'll do that. What if we put in the number 3 for x? The absolute value of 3 is 3. That is greater than 2. Anything bigger than 2, so it's going to be 3, 4, 5, 6, but it's not just that. It could also be 2.1, right? So anything bigger than 2 is, if x is greater than 2, that's going to satisfy the equation. Okay, so I'll start there because that makes sense to me. So does it include 2? No, it doesn't include 2, because if you just have a 2 in here, it's not greater than 2, it would be equal to 2. So we have to do an open circle at the number 2. Okay, and then everything greater than that is going to count. Okay, but we're not done because this is an absolute value. So you have to count the negatives too. So for example, what if I had -3? What's the absolute value of -3? It's going to be 3, and 3 is greater than 2. So I know that this 3 is included, this -3, and this -4 would also be included, and the -5 and -6 forever. What about -2? No, that would not be included because the absolute value of that is just 2, and it would be equal to 2, so that not greater than. So we have to do the same sort of thing on the negative side. So I'm going to make an open circle, and then anything greater than that in magnitude, even though it's going in the left-hand direction. So x is greater than 2, or x is less than -2 are the answers. So this is the answer, and this is the graph of the answer, and you have to graph them all. Whew, this is hard. This is hard. Let's go on to the next one. You're probably thinking, yes, 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 this is easy for you, but this is a little tricky for me to think about. Now, we're asked to indicate, okay, I'm going to get rid of that because it's really distracting. We're asked to indicate on the number line the location of all real numbers, because that's the domain, whose absolute value is equal to or less than 3. So it's going to be numbers that are only 3 or less in magnitude. So let's think about it. What if you have the number 4 here? The absolute value of that is 4. 4 is not less than 3. So this number has to be less than 3. Does it include 3? Yes, it does, because of this equal sign. So I'm going to start at 3, and I'm going to include 3. So I'm going to make a circle here. Oops, that's funny. It turned into an arrow. I'm going to make a circle there. And I know it has to be less than 3, so I'm going to take that all the way down to 0. But what about the negative numbers? Because it's going to be the same on the other side, right? It makes sense to me that it would be like a mirror image because of the absolute values. So -3 would be included, because if you think about -3 here, -3 is less than or equal to. So because of this equal sign, the absolute value of -3 is equal to 3, so that counts. And anything less than that, meaning distance to 0. So -3, -2, -1. I guess I shouldn't say less than, because less than kind of means that way, and that's not the case. It's this. So yeah, that's it. That's the answer. The answer is this graph. Does that make sense to you? Hopefully. Let's do another one. 102.3. Okay, jackpot. I hope this makes sense to you. If it makes sense, congratulations, because I know it's really tricky. The absolute value of x is less than -4. So we haven't graphed a solution for this one yet, because is there anything that it could be? How could the absolute value be less than a negative number? Anything less than a negative number on this would mean this, but then you can't put in -5 here, because then you would be taking the absolute value of that, and that would be +5, and that's not less than -4. So is there any way that you could stick any number in here, take the absolute value, and have it be less than -4? No way. You can't. It's impossible. So they gave you a question that has no answer. This does not even make sense, because the absolute value, according to the formal definition, remember, A A was the absolute value of a positive number is the positive. B was the absolute value of 0 is 0. C was the absolute value of a negative number is its opposite, which is going to always end up being a positive number, because the opposite of a negative number is a positive number. So no way you can get this. It doesn't make sense. So what you have to do for this is either the answer is a set of nothing, or the null set, which has a symbol like this. It's called the null set, meaning there's no answer to this. There's no way. This is an impossibility. Okay. 102.4. I know. I'm thinking this too. What is wrong with the people coming up with these problems? They need to get a life, don't they? Like, what kind of mathematicians are coming up with this? Okay. What if x is, we switch the sign? What if we switch the sign? Because before we had this, less than -4. What if we have greater than -4? Okay, so we want something that is going to end up being greater than -4. And turns out that the lowest number you can get when you put anything here is 0, right? Because the absolute value of 0 is 0. We know that. That's rule B in the formal definition. And then the absolute value of any negative number is its opposite. And its opposite is always going to be positive, and that's always going to be greater than -4. And then the absolute value of any positive number is a positive x, and that's always going to be greater than -4, because -4 is on this side. So anything we do is going to make it greater than -4. So the answer to this one is everything. All real numbers will have an absolute value that's greater than -4. They have to, by definition, because the definition shows you that the lowest number you can get as an answer is 0. So why isn't it just this? Because they're not asking for the answer, they're asking for what goes here. And could a -2 go here? Sure, why not? What if we put a -2 right there and take the absolute value? Is it greater than -4? Yes. So that satisfies the equation. So x could be -2, and it could be -4, and it could be -6. It could be any real number. It turns out if you plug anything into here, you'll make it work. It'll be greater than -4. That one was tricky for me, I have to say. Ugh, I'm going to lose my freaking mind. I know. Just when you think you understand absolute values, they start giving you these inequalities, and it's like crazy hard. Okay, so let's do one where we have to do a little bit more work to find the answer. I know, a little bit more work. So if they give you an inequality like this, first you have to simplify this inequality, because this is not simple enough. So we're going to multiply both sides of the inequality by -1. -1 here, -1 here. And that's in order to isolate the x to one side. Like, this is a problem, and we have to isolate the x first before we can graph it. So if we take the opposite of the left-hand side, now it's going to be the absolute value of x. And then whenever we multiply both sides of the inequality by -1, we have to reverse the symbol. Do you remember that rule? Reverse the symbol, and then you get a +3 here. Ugh, tricky. Tricky. So they gave you this, but you end up with this. And what is going to make an absolute value that is less than or equal to 3? So if I look at the positive numbers first, what if I put the number 1 in there? The absolute value of 1, is that going to be less than 3? Yes. So that is going to be included. What if I put in 3, like the number 3 here? The absolute value of 3 is 3. That's equal to, so we are going to include 3 in our number line. What about 4? No, the absolute value of 4 is greater than 3, so that doesn't work. It's not going to be that. So on the positive end of things, it's going to be this, all inclusive up to the number 3. And then it's going to be its mirror image on this side, because anything less than 3 in magnitude is going to count. And so if you plug in -3, the absolute value of that is going to be included. So do you see how we got this? That's tricky. That is tricky. Let's do another one and make sure we know how to do it. Yeah, we do like it. I know, we can do another one. One more, last example. Let's graph this. So first things first, we have to solve this inequality. It's not good in the condition that it's in. So let's solve it. First, we're going to add 2 to both sides. Add 2. Then you're going to have negative absolute value of x is greater than, because that cancels out, -5 plus 2, -3. Then we're going to multiply everything by -1. Again, just like before. And this by -1. So then we're going to have the absolute value of x. We're going to switch the sign, and then we're going to make that a +3. So we don't forget to reverse that inequality symbol. Now this is like one of the problems that we've done before. So what can we plug in for that? Anything from 0 to 3, but not including 3. So that's an open circle there. Because if you just plug in a 3 right here, there's no equal sign, so we can't do that. Same thing on the other side. We're going to go all the way from 0 to -3. Okay, so make sure that this graph makes sense to you. If it doesn't, let me know, okay, because otherwise you'll have trouble with these. I know. Okay, wake up now, Zach. We're done. We're done with the lesson. Go do your homework. All right, love ya. Bye. Have a great day.